Hello everyone, welcome to today's class. In this lecture we'll continue with the topic of AOD, another application, Maxima Minima. Okay. So see, a curve can be like this. We talked about like it can be increasing, then it can be decreasing, or the other way around also. It can be decreasing and then further again increasing. So this point here, it creates a local maxima here. This point here, it creates a minima point here. Now we need to know these points, okay, that at which point something will be maximum or something will be minimum. What are the conditions for it? Okay, so first thing is, in order for maxima or minima to exist, the first thing is that for maxima or minima, your f dash x means the function of x, whichever function it is, in terms of x it is should be 0. If it is in terms of x, then f dash x 0. Suppose it's in terms of r, so then f dash r should be 0, or it is in the function of t, so function f dash t means the first order derivative should be become 0. Okay, you solve that, you get the points of maxima minima. Okay, and get x is equal to, let's say, alpha, beta, gamma. You'll get 2-3 values depending on the equation. Now point is, at this point you can have maxima or minima. You are not sure about this because this condition is not sufficient to tell us about that. Now in order to get the final result, whether it's maxima or minima, you have to do a second order derivative test, that's f dash x. So f double dash x, or the second order derivative, suppose it is coming greater than 0, so we'll say it has minima. Or if it is coming f double dash x coming less than 0, so maxima. So it's opposite, greater than 0 it's minima, less than 0 it's maxima. And there is a possibility then f double dash x comes out to be 0. This value of x, this is known as point of inflection. So at point of inflection, what happens is f double dash x becomes 0. Okay. Let's see a question and go through the steps to understand it more. So first question, we have to find local maxima and minima. Find points of local maxima and minima. Your fx is minus 3 by 4 x raised to power 4 minus 8x cube minus 45x square by 2 plus 105. All right. Now in order to get points of maximum minima means the value where it was getting maxima or minima. So let's say alpha, beta, and another point was there. So we need these points first, then we'll get the maximum value. So f dash x first of all. So differentiate it. So you'll get minus 3x cube minus 24x square, okay, and minus 45x. Negative is common, 3 is common. We are solving equal to 0. Okay, get the value of x. Okay, alpha, beta, gamma. Na? So fine, minus 3x common. So you'll get x square plus 8x plus 15 equal to 0. So minus 3x, this becomes x plus 5x plus 3, okay, equals to 0. We got the value of x as 0, minus 3 and minus 5. Now at these points, okay, maxima or minima both can exist. Now we have to tell at which point it's maxima, is to which point it's minima. Okay, so let's calculate f double dash x. Okay, so I'll differentiate this one more time. So minus 9x square minus 24 into 2, 48x minus 45. Let's check at x equal to 0 first of all. Okay. At x equal to 0, your f double dash x will become 0, 0 minus 45, which is less than 0. Hence, we can say it's maxima at x equal to 0. Similarly, you calculate again at x equal to minus 3. Okay, so again, all we have to do is judge the value whether it is greater than 0 or less than 0. So f double dash x is equal to minus 9, 3 square is again 9, minus 48 into 3 minus 3 minus 45. Okay. Minus 81 plus 24, 144 minus 45. Okay. So this value comes out to be 80, 40, 120, still nowhere close to the 144, so positive value. Positive means greater than 0 basically. If it is greater than 0, definitely that means minima. Okay, minima at x equal to minus 3. Okay. Lastly, you have to check at x equal to minus 5. So again, f double dash x minus 9 into 25 minus 48 into minus 5 minus 45. Okay. That gives you minus 225 plus 48, 240 minus 45. So this time it will be negative, means less than 0, again maxima. Okay. So now I can say that maxima at x equal to 0 and minus 5. At these, both of the values will give us a local maxima. What is the meaning of local maxima here? So you can again have a maxima like this. So this will also be a maxima. This is also a maxima. This is also a maxima. Okay. Now out of those two, one is absolute maxima. Absolute means clearly you can see at this value, let's say gamma, we can see the value of y will be much more. Okay. So, but both are maximas as such. Okay. But there is absolute, if I had to talk about absolute maxima, that happens at gamma. Okay. So maxima at these values and minima at x equal to minus 3. If you want, we can calculate the values also. What is the value? We are not going to do that in this question. Okay. So this is how you calculate maxima or minima, whether at some point you will have maxima or minima. Okay. All right. Let's deal with the concept of absolute also with this same question. We have already done so much in this. Okay, we have two maximas also. Let's find the value of fx at x equal to 0. Okay, let's calculate fx function value. What is the function? So at x equal to 0, your fx is how much? What was the function? Oh, negative, 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 0, 0, 0, 105 it is coming, plus 105. Okay. And if we calculate at x equal to minus 5, okay, so that is f of minus 5. You put the value of x as 5 in the function, you will get 295 by 4. Okay, this is just for your reference. Okay. Now out of these two, if I ask you which one is the absolute maxima, means both of them has the maximum value, means most of the, if I plot the graph, we'll have the peaks at 0 and minus 5, and this will be the maximum value. But which one is the absolute? So if I have to take the absolute, we have to calculate the exact value. Absolute maxima at x equal to 0. and function has the maximum value 105. This is the maximum value that function can achieve. Okay. All right. We're done. Similarly, we can calculate minima also, but there are only one minima, so definitely at that value will be your absolute minima. So no need to worry about that. Okay. All right. Sometimes the question comes like this. They give you an interval that you have to find maxima or mina in some particular interval. Okay. So the question is like this. Same idea. Find maximum and minimum value of fx 2x cube minus 24x plus 107 in interval 1 to 3, closed interval. Okay. So whenever they say closed interval, so he's talking like you plot the graph. So let's say I'm hypothetically drawing this. This value is 1, this value is 3. So at some particular point in between you'll have maximum minima, but the problem is this interval is closed. My bad. This is closed. Closed means we have to check at exactly x equal to 1 also. Now the point is, in order to check maximum minima, we usually, the idea is to compare it with the points which are on the right and left. If the value is more than the point which is on the right as well as the left, we'll say that has a maximum value. Like this is the maximum. Na? So this point particularly will have more value than the point on the right or the point on the left. So we can compare all the points in between 1 and 3. The problem is that exactly at x equal to 1, we don't have anything to compare. So that method that we have talked about actually does the same process, just that uses the calculus. And in doing so, it checks the points on the right as well as left. The problem is this interval. If we are checking in this interval, the function doesn't exist outside this because we are supposed to check in this. So how can we check at this point? Then there is no direct way to check it. There is no complicated way to check it. The idea is to you check your maxima minima, you check your maximum value and minimum value, and you check separately x equal to 1 and x equal to 3 by putting the value directly. So let's calculate f of 1 and f of 3 directly. Okay, first of all, so this is just one additional step when the interval is given and it's a closed interval. Remember that. Open interval doesn't matter. We just directly do f dash x. So I'm doing this step first and then we'll do the differentiation part of it. Okay. Maximum minimum. So f of 1 is 2 minus 24 plus 107. That gives you 109 minus 24. So that's 5 and 8, 85. Okay. Looking at a good value. F of 3. 2 into 3 cube 27 minus 24 into 3 plus 107. This gives us 54 minus 72 plus 107. 54, 18, 18 plus 107. So that is 15, 125. Okay. This is 109. F of 1. 85. No? That was correct. Okay. So we have separately calculated this value. Now let's check whether in between. See, this is one of the possibility. The possibility is like this also, na? That the function can be like this, So it can have a maxima in between or a minima or multiple maximas and minima. So we don't know. It's just that with the help of mathematics we can find this without actually plotting the graph. So f of f dash x, let's do that. Now we are trying to maximize and minimize the function, so let's do the differentiation steps. Let's differentiate. So 6x square minus 24 equals to 0. Okay, f dash x equal to 0. That's the first condition. Get the value of x. So x comes out to be x square is 4, x is again plus minus 2. So plus 2 and minus 2. So for both values we have to check. So now as such the question is asking just your maximum and minimum value, na? So why bother with second order derivative test? See, even if after doing that you need to find the maximum and the minimum value. So you need, when the question is saying find the maximum and minimum, if nothing is mentioned, that means he's talking about the absolute values. Okay. If I give you some function and I ask you to get it maximized, you will not get me two maximas. You will get me only one single maximum with the maximum value that I can get from this fx. So what you do, we have already calculated f of 1, f of 3. Now if you want to do this directly, just directly calculate f of 2 and f of minus 2, and then let's compare the values, this value, this value and this value. We'll see, because see, out of these values something will be maximum, something will be minimum. That's it. Rest of the values will be in between. So we can go for double derivative test also, but I'm just saying that effectively we have to compare. So let's calculate at 2 and minus 2 also. Okay. Also we don't have to calculate at minus 2 because this is not in the interval, not in interval, because the question says we have to look for the maximum and minimum in 1 to 3. So though the function can have a maxima or a minima at this point, but it's out of our domain as such. So we'll just have to calculate f of 2. So let's calculate 2 into 2 cube minus 24 into 2 plus 107. Okay. So 8, 16 minus 48 plus 107. That's minus 32 plus 107. 5, 7, 75. So now you have three values. One is 85, one is 125, and a maxima in between. Okay, maxima or minima, whatever that can be, but the point is the value is 75. So out of these three values, if I ask you to choose the maximum and minimum, I think you can clearly choose this. This is the maximum value of fx, and this one is the minimum value. So just use your common sense for this. You don't have to do double derivative if the question is asking only for the maximum and minimum values. Okay. Yes, you can verify whether that will be maximum or minimum, but the point is still whenever this closed interval is there, we have to compare these two values separately, 1 and 3, the interval that is mentioned in closed, we have to separately compare that. Okay. If it's an open interval, I'll say at this value, that whatever value we got, that could be your maximum or minimum. Okay. Now that we have already done this, let's move to the application part, the real part of it. Okay, so maximizing a function, it's very simple. Okay, because you have to differentiate, get the values and compare. Okay, we have seen the comparison with this also, I have double derivative test also. Now let's see the real application. Okay. The question says find two numbers whose sum is 24. I think this is the same question. Once again, I'll get the printed version of it. It'll save us time. All right. Okay. So this is our question. Find two numbers such that whose sum is 24 and product is as large as possible. So we have to maximize the product, but the constraint is that sum is restricted to 12. Now remember, if you want to do this without even lifting your pen, remember that symmetry is the key for maximum or minimum. In order to maximize or minimize anything in the nature, symmetry will play the role. If I ask you to divide this in two parts symmetrically, you'll divide it 12 12, and interestingly this 12 12, the product of this will be the maximum value. It's just that now we are going to use differentiation to prove it. Let's see. I've already given the answer before even starting the question. Okay, symmetry, that's the key to maximize or minimizing things. Now the question says find two numbers. Now, so whenever he's asking for two numbers, let's consider the first number be x. Let the numbers are, one number will be x, another will be 24 minus x, and what will be the product? The product will be x into 24 minus x. Now whatever you want to maximize or minimize, we'll call that as your f of x. Okay, and now forget about the whole question. You have a situation, you have a function in terms of x, just maximize it. So what do? We differentiate this. Okay, so let's rearrange the function. 24x minus x square. Okay, that's the function. Okay, now calculate f dash x. So 24 minus 2x, you put it equal to 0, you'll get 24 is equal to 2x, x is 12, and I told you the value will come 12 before even starting. Now point is, at this value, as per the differentiation, maximum or minimum can exist. Both can exist. Now in order to verify whether it's maximum or minimum, see, if we want to finish the question as quickly as possible, the moment we get this value, we'll say, of course the question is asking for maximum, so that means for this value it will be maximum. But if you want to justify this, do the double derivative test. F double dash x, what's coming out to be? It's coming out to be, if we differentiate this one more time, 24 differentiation is 0, minus 2. It's coming minus 2. Clearly it is less than 0. Therefore, only maxima will exist. Okay, at this value, at x equal to 12. Okay, so the numbers are, one is 12, another is 24 minus 12, also 12. Okay. All right, done. Let's see the next one. You have to find two numbers, pretty much same idea. It's just that now he's saying that the product should not be the maximum. It's just that xy cube should be maximum. Now this time I cannot play with symmetry. The reason being, if I divide this in 30 and 30, let's say x is 30 30, clearly y cube is there, so more dominant factor. Okay, so if I increase my y, clearly I'll can and decrease my x slightly, clearly I can get this product more. Okay, so this time symmetry will not help you. Okay, in that case it was not always, every question will be done like this. So this time what do you do? If you want this to be maximum, let's call that as your function x y cube. The problem is that I've written here x f x, so the whole question should be in terms of x, so the variable should be single, not multiple. So how do I get rid of this y? I can put y as 60 minus x, of course, one option. But I'm just saying, for an instant, forget about like this is some function. I'm saying I want this in a single variable now. So rather than substituting y, let's substitute x. What will be the value of x? 60 minus y. Why I'm doing like this? Why not that or the other way? Because the multiplication will be easier. Also, I will differentiate this easily. Otherwise, if you you try to put here 60 minus x, no? 6x into 60 minus x whole cube. If you open it, it's a lengthy expression. If you don't, you still have to use ub and including a slightly chain root. So if you're comfortable, you can, but I'm just saying you have to maximize this. You have to decide which variable to change, which one makes it easy. So same idea, is just that now instead of x you have y. Okay, so this needs to be maximized. So same thing, f dash y, differentiate it. So I think before differentiation, just multiply this, it will be simpler. 60y cube minus y raised to power 4. Differentiate it. So 180 y square minus 4 y cube, and you are solving equal to 0. So take 4 and y square common. 45 minus y equals to 0. Okay. So you get two values of y is 0 and y is 45. Now, just using your common sense, we are calculating product. If one value is 0, the product will not be maximum. So we can reject this directly without even calculating anything. And this will be the value at which maxima will occur. So y is 45. That means it implies that x is 60 minus y, so 15. So that's your answer, x 15, y 45. But let's justify this again, that yes, at this value maxima and minima both can occur, no? So let's justify this, f double dash y. Let's differentiate this one more time. So 180 into 2, 360y minus 12y square. Okay, let's take common, 12y common, so I get 30y minus 12y I've taken 1. Yeah. Now if I put, we have to check at y equal to 45 now. So check it when y, if I put y as 45, I don't have to get the value. All I need is whether the answer will come positive or not. So 12 into 45, it will be positive. 30 into 45 minus 1 will be also be positive. So positive answer will be there. So I don't have to solve anything more than this. So it's a positive, so it's greater than 0. It's coming out to be minimum. Interesting. Why? If we have we differentiated it wrong? Oh, sorry. My bad. I've written it wrong here. Sorry. It is taking common. It is coming 30 minus y. Yeah, now it's correct. So when if I put y as 45, the outside 12y is positive. So 30 minus 45, this will make it negative. Yeah, now it's okay. So anyway, it's coming out to be negative. So that means less than 0. That means maxima. Though I already told you that if you are getting only one sensible value, that will be your maxima or minima. Okay. 14 done. All right, this is done. This is done. Okay, next. All right, let's look at this question. He's saying find two positive numbers whose sum is 16 and sum of whose cubes, means let's say two numbers are x and y, na? So one is x, one is y. So x cube plus y cube should be minimum. Sum should be 16. X plus y is 16. You have to solve this. I can see symmetry here because x cube plus y cube, there is no dominant factor. Pretty much I'm guessing you should get this as an answer, 8, 8. Okay, anything else you'll get more. Let's check it roughly before even solving. 8 cube, 5 and 2, 5 and 2, 1 0 2 4. If we do 7 cube and 9 cube, 9 cube is 729, 7 cube is 343, more than 1024. So yeah, answer will work. Let's justify again. Okay. So fine, the function is x cube plus y cube, but we want it in single variable, so x cube plus y will be also 16 minus x whole cube. So this is x cube, let it be, I think that's okay, because if you even if you open this, there is no so much useful point in this. Okay. So what's our f dash x? F dash x is 3x square plus 3 into 16 minus x whole square. Then differentiation of 16 minus x will be minus 1. We have to solve it to equal to 0. Take 3 common, so you'll get x square minus 16 minus x whole square is equal to 0. Okay. One second, let me rewrite this. X square minus 16 minus x whole square equals to 0. So a square minus b square we can apply, or if you want you can literally open this. So x minus 16 plus x plus 16 minus x equals to 0. So 3, you will get 2x minus 16 into 16 equal to 0. So basically 48 minus 2x minus 16 equals to 0. If still you take 2 common, you get 96 bracket 2x minus 8, sorry, x minus 8 equals to 0. You get to get a single value. You're going to get a single value of x. X is 8. And I told you that from the symmetry, we can say that the maximum value will occur at this. This time in the previous question it was not, because if it was x square y square, I could have said yes, symmetry could work. You can try whether it is working or not, but that's a pretty good guess. I think it should work. But since y cube was there, so it's a more dominant factor than x, so we cannot have this. Here x cube plus y cube both have equal powers, equal contributions, divide them symmetrically. And I can prove that the cubes are minimum because I'll calculate f double dash x, that at this value minima, maxima or minima can occur, but I can justify that it is going to be minima. Why? Because calculate your f double dash x, means this thing differentiated one more time, you'll get 96, which is greater than 0, definitely minima. Okay, greater than 0 is minima. Okay, so for these kinds of questions I think you don't even need to use differentiation. What you can do is you can use symmetry, but not all questions. Again, same thing, you can use it for few questions, not everything. Okay, let's look at the next question. Interesting question, practical scenario. Okay, let me see if I have a figure for this. We don't, I think, or do we? No, we don't. So we'll have to draw our own figure. This is slightly a question of analysis. That's why I was thinking if I could get one figure. I got a figure. Fine, I'll draw it. Let it be. Let's see. He's saying there's a square. All right, let's take a square. He's saying you of 18 centimeter, so fine, 18 centimeter, and it is made into a box without top. Okay, by cutting a square from each corner, means from each corner you are again cutting a square. Okay, let's take a square here. All right, let's say this is the squares that we have cut down from the corners. Okay, we have removed this. Okay, so effectively you have this sort of a boundary. Okay. The red part is removed. Okay. Clearly, see, the problem is this is in 2D. If you flip this about this side vertically, take this side, flip it vertically, flip it vertically, flip it vertically, you'll get sort of a box. Okay, it's in 3D, but you will get sort of a box like this. If you flip all the sides vertically, you can literally do this by taking a page. Okay, just cut some square from the corners and flip each side. Flip this one, flip this one, flip this one, flip this one. Okay, but the point, you have to take it out in vertical. I cannot show you that here. Okay. The point is this thing, this length, the square, the side of the square which you removed. Okay, let's say this is x. This will become this height. Okay. Rest this square or the whatever shape this is, interestingly this will be a square, but this shape in the middle will be your acting as your base. Okay, this is the base, this base I'm talking about. This is the same base. Okay, now we need to he's saying what should be the side of the square to be cut off so that the volume of the cube that is created has maximum is maximum overall. Volume is maximum. So anyway, of course, volume of a cuboid is length into breadth into height. So all we need is dimension of this box. We already calculated that this height is x. All we need is length and breadth. So let's see. This is completely 18. This is x. This is x. So that means this is 18 minus 2x. That means this is also 18 minus 2x. Same thing happens on here also. 18 minus 2x. So 18 minus 2x, 18 minus 2x. So base itself is a square of 18 minus 2x. So the length of the base is also 18 minus 2x. Breadth is also 18 minus 2x. So I can say volume is 18 minus 2x whole square into x. So this is clearly a function of x. Let's call this as our f(x). And we have to maximize this. So same idea, differentiate it. Okay. You can open it also. You can do it directly also. It's your call. They have not done it. Anyway, okay. Let's differentiate directly. Let's take safe side. Let's open it this time. Okay. So this is 324 a square plus 4x square b square minus 18 to 36 into 2 72x into x. So this becomes 324x plus 4x cube minus 7x 72 x square. Now this is a simple function. We can differentiate f dash x. In order to maximize, we have to differentiate it equals to 0. So 324 plus 12x square minus 144x. We can take 12 common, I think. So if we take 12 common, we get x square minus 12x, and this is 12, 24, 24, 84, 6, 7, 27 equals to 0. So we have to so let's middle term split this. This becomes x minus 9, x minus 3. There is some change in sign. This should be positive. Sorry. X square was positive, x was negative. This 324, this should have been positive. Now it's okay. So we got the value of x as 3 or 9. Okay. You can directly reject 9. Reason being, if x is 9, 18 minus 2x will be 0. That means you will not have any base. Then volume will be also minimum. So means at x equal to 3, we can say it is maximum. But let's justify it. That at f double dash x, for that we need f double dash x. So differentiate it again. So 324 is differentiated, you get 24x minus 144. Okay. So for this, though we rejected and accepted the value based on our common sense, but at both of these value, maxima slash minima can occur. So I think 9 is a condition for minima. That's why it is coming 0. Na? So we don't know at which value which will occur if we are doing just mathematics. So let's see, at x equal to 3, f double dash x is 72 minus 144. That is less than 0. So maxima, we already knew that. Sorry. Similarly, at x equal to 9, f double dash x is 9, that will be 240 minus 24, 220, 216. Minus 144, definitely greater than 0. Point is, it is 200 something, so doesn't matter. So it's minima. So I told you that x equal to 3. So what is the maximum square we can cut from this square tin box? That's x equal to 3. Okay. If you remove that square, you will have the maximum value. All right. Let's look at the next. I think that's it. So far these are the basic applications. Okay, that's it for this lecture. We'll continue in the next class. Okay, all right. Good day everyone. See you in the next class. Bye.